Hi guys, let's go through question 1. Quadratic function is given y equal to x to the power of 2, take away 8x plus 12, and we need to find x and y intercept. So how are we going to do that? So let's start. Part A. Finding x intercepts. We do know that y is equal to 0, and now we are substituting y equal to 0 in the original equation, which is this one here. So it's going to give us x to the power of 2, take away 8x, and then plus 12, and it's equal to 0. So to solve this, maybe the easiest way, it would be using graphics calculators, but I'm going to use the method called factorization, which you have seen before, just to revise. And the first thing we're going to do, as the coefficient of x to the power of 2 is 1, we are only interested in constant value, which is positive 12. And we are looking for two numbers when we multiply them to give us 12, or pretty much we're looking for the factors of 12. And there are a few, so 1 and 12, so negative 1 and negative 12 as well, it will give us 12. And before I continue, so the other number of interest is negative 8, which is coefficient of x. So we're looking for two numbers when we add them together to give us negative 8, as well as when we multiply them to give us positive 12. So instead of going through all factors of 12, we may think, okay, maybe it's something, 6 and 2, so I'm going to have 6 and 2, and if they're positive, 6 times 2 is 12, but 6 plus 2 would be positive 8, and we do need negative 8. So therefore, I'm going to consider both negative 6, negative 2, which when I multiply is gonna give me 12, which is beautiful. And if I add them together, negative 6 and negative 2 is gonna give me negative 8, which is good. So we found two values of x. So the next step, it would be just to rewrite the equation, factorize it. 6 take away x take away 6 times x take away 2 equal to 0. And now to solve this, and in order for this expression to be equal to 0, either x take away 6 has to be equal to 0, or x take away 2 has to be equal to 0. So this is only going to happen if x is equal to 6 and if x is equal to 2. So we do have the values of x. So we do have x-axis, so x intercepts actually, and now we're gonna find y-intercept. So in order to find y-intercept, x has to be equal to 0. Similar to what we have done before, but now instead of x, we're gonna have 0. So y is equal to, and you can replace x by 0. You don't need to, but if you do want to have all steps, so and it's just going to give us, this is 0, this is 0, and we are left with 12. So the y-intercept is 12. Beautiful. So that would be part A, x and y intercepts. Part B now. To find the coordinates of the vertex, we're going to use x-intercept, x equal to 6 and x equal to 2. And in order to find that, so we're going to put them together, x1, which is 6, plus x2 divided by 2. In our case is x plus 2 divided by 2, and it's going to give us 4. So the x-coordinate of the vertex is 4. To find the y-coordinate, sub x equal to 4 into original equation again. So it's going to give us y equal to 4 to the power of 2, take away 8 times 4, and plus 12. And now, again, if you do want to go through steps, you're more than welcome. But you can calculate straight away and just say is equal to negative 4. Now we do have the coordinate of the vertex. I'm just going to put here v, 4 and negative 4, and the axis of symmetry is equal to 4. So this is axis of symmetry. Just going to write axis of symmetry. Axis of symmetry. So the last part of this question is to graph the function and show all informations that we already have. So let's move this up, and part C now. Part C, draw the graph. So let's have x-axis, y-axis, and use the informations given. So x is equal to 2, let's say this is 2, and x is equal to 6. So we do have x intercepts. And now we're going to look what is y-intercept. So we can go back here and look what is y-intercept is 12, which means when x is 0, y is equal to 12. So it's going to be here. So it's going to be 12. And we do have the turning point or vertex, so which is 4 and negative 4. Let's say 4 is here, the middle, 4 is here, and I'm gonna expand this a little bit, and then negative 4 is there, dot, and this is my turning point, vertex, who has the coordinates, which one has coordinates 4 and negative 4. And now the last part, it would be to connect points given. So we do know it has to go through 2 and 6, and it's gonna turn here, just like that. I'm gonna try to do my best here. Yep, okay. So it's not the best looking quadratic graph, but you do get the idea. So I'm just gonna put y is equal f of x. So this would be the first question, and now let's move to another one. So question 2. Question 2 is, write y equal x to the power of 2, take away 10x plus 15 in the form x take away k, everything to the h, actually, x take away h, everything to the power of 2, and plus k by completing the square. So, in order to use the method called completing the square, so what we're gonna do here, it's y equal to x to the power of 2 take away 10x. Now, the first thing before I add 15 here, I'm gonna look what is coefficient of x, and it's 10. It's actually is negative 10, but we're gonna ignore negative, just gonna look at the 10. And half of 10 is 5. I'm gonna use different color. Now I'm gonna add half of the coefficient of x to the power of 2. But we do know the equation needs to be balanced. We can't just add something, So in order to keep it balanced, I'm gonna take away the same number. And now it looks like, nothing has been done. So nothing has changed, even though it has changed, but it's good balance. And then we shouldn't forget that part here, which is plus 15. So next step, y equal to, let's look at the first 3 terms, this one here, and try to rewrite this as a perfect square. So that would give us x take away 5 and everything to the power of 2. I'm just going to have here in the corner, just to remind you, the perfect square a plus b, everything to the power of 2, is equal to a to the power of 2 plus 2ab and plus b. If you have minus here, different color, minus here, it's going to be minus there. So this is the perfect square. So, and here, what is important to actually recognize it, the perfect square, and rewrite it. So, and if you're not sure if you do have correct one, you can always expand and see if it does match this part here. Now, the last bit is actually negative 5 to the power of 2 is 25, and then plus 15. So, and y is equal to x, take away 5 to the power of 2, negative 25 plus 15 is negative 10. And if we do have to find vertex here, so vertex would be positive 5 and negative 10. As you can see, we are looking at this number and that one. So let me just have circle around this rule, maybe more colors. That is perfect square. One more thing that I would like to add here. So often I have seen kids writing this part here. Okay, I'm just gonna go here on the side. Negative 5 to the power of 2 often I have seen is 25, or negative 5, everything to the power of 2 is equal to negative 5, so which is no, no, big no. So negative 5, everything to the power of 2 is pretty much negative 5 times by itself twice. Negative negative would give us positive, and negative 5 to the power of 2 is pretty much you copy this negative here, and 5 to the power of 2 is 25. Just, yeah, small info on the side. And I think that would be it for those two questions. Bye.